Find the maximum number of elements in a subset. You are given an array of positive integers nums. You need to select a subset of nums which satisfies the following conditions. You can place the selected elements in a zero-indexed array such that it follows the pattern x squared, x to the fourth, and so on. So you double the power. And then you work your way back down to the original x. To specify, it's a subset, not a subsequence, meaning that we can rearrange it. So it's really just any of the elements. So I actually don't know where to start here. The topics are array, hash table, and enumeration. So how do we find this pattern? So right off the bat, I'm thinking maybe it'd be helpful to have like a count, an appearances count. Okay? And in that way, because for most elements, we're going to need at least two of them for it to be valuable in a sequence. Can the output be a sequence of 2, or does it need to be an odd-numbered sequence? I don't think that the output... I think that it has to be at least 2. Or at least it needs to be an odd number. Let's see. Can we get anything from any of these? No, not really. That's not helpful. Okay, so appearances count appearances of all elements. Right now, I'm not worried about that because that'll just take up on time and on space. So that won't really cost us anything if we do that beforehand. That's like a freebie. Now what do we do with that? How about like a greedy approach? And here's what I mean. Choose the highest element. See if, because that has the best chance of making the most. Choose the highest element, as that has the best chance of making the longest sequence. We work our way down from there. From there, checking if the map of it would be let's see. Oh my gosh, I'm forgetting my math here. It'd be square root, right? Yeah. There's the square root. And are they integers? Yeah, they're integers. Well, first we could just check if the square root thing is an integer and that map of the square root is at least 2. Okay, so here's what I like about this approach is that if you have 16, if you have 2, 4, 8, no, sorry, 2, 4, 16, 4, 2. No, if you have 2, 4, what's 2 to the 8th? 256, yeah. I should know that. 2, 4, 8, 16, 256, 16, 4, 2. If you find 256, then you're going to check for 2 16s. Say that's true, then check for 2 4s. If that's not true, then we don't need to check 256 again. Or, sorry, 16 again. Because we know that 16 can't make a bigger subsequence than 256. But I think I'm overcomplicating things. So how about we start by sorting nums? Then we'll just have an appearance, and the reason why I want to sort nums is because I want to work down basically from the biggest possible number. Take that greedy approach. Appearances is that. It's going to be a dictionary. Now we're going to say for num in nums. It doesn't matter that we sort it. I have a feeling it's going to be longer than n log n. So you might as well sort it in line. For num in nums, if num in appearances num plus equals 1. Otherwise, appearances num equals 1. Okay, so a quick count. Okay, so now what we want is to basically work our way down. I still need to figure out that key thing, and I should do that before I keep coding. would it be better? I'm just gonna see this through. I'm not set on it, but would it be better build up? i.e. start with lowest number that's greater than 1, because 1 can only make... I wish it was more clear about that. Okay, wow, that was a soul read. I was going to ask about the ones, but the ones might be a special case. That's my thought. Start with the lowest number. Do we build up or do we build down? Let's see through both. So first, let's write down, how about take set of nums. And then that way we can just iterate numbers without being redundant. And say unique nums equals set of nums. Okay, so build up, i.e. start with the lowest number and see how big a sequence you can make. I kind of want to handle the ones differently. Because the thing is that if we're counting the ones, my thought is to basically, okay, so we have 2, and then 2 squared is 4. So we check to see, does 4, is there 1 4? Because if there's 1 4, then that sequence is 3. Are there 2 4s? Because if there are 2 4s, then you keep going and see if there's a 16. But if you treated the ones the same as anything else, then that would be an endless loop, because you would say, are there ones? Are there ones? If so, check if there are 1 squared, which is 1, and there still are ones, so it would just be an endless loop, and it would think that you can make them forever. So we would have to keep track of which ones we've already used, but we wouldn't have to do that with the other ones, which makes me want to use the ones on their own. Okay. So, what do we say special case for ones? As 1 x 8 equals 1. Okay. We could say if unique nums 0 equals 1, then how we say you have like a max length, and that holds on to the max length. And so we initially just say, since ones will just be a sequence of ones, since ones will just be a sequence of ones, must be odd, handle them separately. And we know that unique nums, the 0, since we have it sorted, no, actually we'll just have nums 0. So we know that this, since it's sorted, if there is a 1, it'll be the first one. So we're going to handle them separately. And we'll say I'm still debating in my head on if it's better to build up top down or bottom up. The reason why I like building bottom up is because then you don't have to deal with square roots, which is a much less clean operation in my opinion. But it could be faster because when you build top down, you can infer some information. Like if you do 256, 16, and then there's only 1 4, then you know that you might as well not check 16. Because you might as well not check 16 to see if that would start anything good. But I feel like that's only for some cases that's really going to end up mattering. I don't know. That's one thought. But let's just try building bottom up because it's simpler in my mind. Since ones will just be a sequence of ones, handle them separately. We're going to say ones count equals appearances of 1. And then if one's count is odd, we'll say we'll do this. Okay, no, actually we don't need it. You don't need to put that into a variable because it'll just be an else for the other side. If one's count is odd, then the starting max length is just the number of ones. Okay, this could be something. Otherwise, it's ones count minus 1 to make it odd. Okay. So, maybe that's an added benefit of building up is that we can start with ones. But I think the ones are kind of separate anyway. Okay, now let's just try building up. For num in appearances, so now we count the appearances. Oh, we actually need to put this before everything. Okay. So now we have 1. Okay. Now we'll say for num, do we need to make this a list? We'll see later on. For num in unique nums, I hope that that's sorted. I think that that's sorted. I'm going to say print unique nums. See if we get anything. I'll just run it. I don't care. Awesome. Okay, so it is sorted. For num in unique nums, we're going to say here we go. For num in unique nums, we're going to say we'll have current length equals 1. Starts at 1. And then for every number that we get through, we add 1 to that length. Okay, so here's my thought on the logic for this. I feel like that's going to come into play. Okay, this might be abstract, but I'm thinking that it actually wouldn't really benefit us that much to see if ending a like because my thought was that we could save time by saying, okay, you know, if we know that it can't get any bigger than this, then cut it off. Which we still might as well do. How about let's make this a list? And how about we say right here, how about we say been used is going to be false times the length of unique nums. Here's why. I'm thinking that basically we hold on to this array, and as we work through the numbers, we see, has this number been used? Because if it's been used, then we don't need to try to make a bigger sequence with it. Here's what I mean. If you have 2, 4, 16, 256, and then 16, 4, 2. And you're saying, okay, we have 2. Let's see if there's the 4s. Okay, yes, we have the 4. Let's see if there's the 16s. Oh, there's only one 16, so we stop right there. If that's the case, then you don't need to do for, because you know. So top down, I'm pretty sure, is the same as bottom up. Because, yeah. You know that if you've already checked the 2's, and the 2's multiplied into a 4, you're not going to get a longer sequence with 4, because all the 2 is doing is stitching itself onto the ends of the 4's. So anything that the 4 can do, the 2 can do better. So how about we say if, so first off, we'll say I in range length of unique nums. We'll say num equals unique nums I. If, no, actually, yeah. Say that no matter what. If bin used I, then continue. Basically, when we use these numbers to make a sequence, if we see that earlier it's been made, then we don't need to bother checking. Okay, I think I've gotten the idea across. Now we just have to actually put that into writing. Okay, so maybe I need to comment this out first. Okay, so we have been used, already been used in subset. It can't possibly make a bigger one. So now we'll say next in sequence equals num squared. No. Yeah. Okay. Because we start with that. While we could say next in sequence in appearances we'll say current length plus equals 1. And then if it's 1, then if it equals 1, then we can just break right there. You need to do this before anything. Otherwise, it must be 2 or greater. Otherwise, it must be greater. If it's greater, then that means you can keep going. We don't even need to do any conditions otherwise, because then I'm thinking we say current length equals current length times 2 minus 1. I'll say parentheses for clarity's sake. Okay. That could be it. Oh, we also need to update next in sequence. Is that right? It must be. Yeah. Yeah. Okay. So here's why. Actually, why don't I just run it? Oh, we also need to make it's not been used I, it's been used. Oh wait, no, it is I. Oh, no. I'm overcomplicating things with that. We'll just get back to that. Oh, because it's counting the ones a bunch of times. So num equals 2. Num equals 2 because 4 is in it. What? Well, you could do 2, 4, 2, can't you? Oh, I see. Because there weren't 2 2s. It only needs 1 4, but there aren't 2 2s. So you might as well say if appearances num equals 1, then we'll just put this in and then we'll say continue. Does that work? That'd be cool if that worked. Does it work well? Really? Is my math wrong? Current length equals 2. Oh, because it skips that first one. Okay, I have a feeling that this will still be too slow. Okay, we gotta get rid of those print statements. Oh, wait, no. What? Why is num equal 1? Huh? I'm sorry. I was so lost there that I was going crazy for a bit, and so I was a bit quiet. I apologize for not talking for a bit. I gotta work on that. So we did not go with the greedy approach. I wonder if we can go even faster, though. So the reason why I didn't implement that bin used thing was because I would have to figure out some way. I'd have to use index of, and that can use on time. So in some cases that can be useful, but in other cases it's not. So I don't know how that works so well. Basically, so we count all the appearances. We have a max length that at least is 0. We have skip 1, and then since the 1s are handled differently because 1 squared will still equal 1, we can just say, okay, count the number of 1s. If there's even 1s, then reduce it to the nearest odd number by subtracting 1. Then you get the unique numbers, so you can go through each number only once at most. If there is a 1 in the array, then skip the first number in that unique nums. If there's not, then start with the first number. Then take that number and say, okay, if we only see it once, then just stop there. No need to look to see if there's any more, because you need at least 2 of these numbers to surround something. So you can't surround anything with this number, so it's going to be at most a subset of itself. If we get past that, then what we can do is we can say, okay, continue on, square it, and the current length of this subsequence is 1. We loop through, squaring it as long as we find that next square in appearances. For every time we do, we up the current length by 1. We can get rid of this. If appearances, if the next number in the sequence only appears once, then we can just stop right there. We don't need to bother seeing if the next one appears. We don't need to bother seeing if the next one appears. Well, if there's another number in the sequence, because we don't, the current number can't surround the next number. This number has to be the peak. Then we square it, and then we just go back over. And yeah, I didn't really explain this one that well because I myself was pretty confused. But then at the end, basically, since what you're doing is you're only really collecting the length of it in one direction. So to make it be to mirrored, you do double, and then you subtract 1 because the middle element only appears once, and then you just compare, and then you just set the max to either itself or the new one, provided it's greater, and then you return that max length. And yeah, that's it. That was a weird one, but we got it done. Learned a couple valuable lessons there. This will be worth looking at some solutions. Oh, wow, map and set. Oh, okay. So the submitted solutions didn't really use anything much different to me. I just, I had a little bit of a different way of calculating it, but it really didn't cost anything in terms of time. They even did this thing. Oh, and they used delete instead of my skip 1 thing. Not a big fan of delete, to be honest. But I used up more memory, so who's to say? Awesome. All right. So I didn't really explain that one so well. We just basically, to summarize, going through all of the numbers, only one time, seeing if the square of that appears at all, seeing if it appears only, in which case the sequence has to end there, seeing if it appears once, in which case the sequence can only go one more, or seeing if it appears twice, in which case you keep going. And you just do that for all the numbers, and you'll have calculated all the maxes, and somehow I got a good runtime out of that. All right, sounds good. Shout out to sets and maps. Thank you very much.